I'm Anil Kumar. Welcome to my series on quadratic equations. We'll begin with understanding how to convert any quadratic equation in standard form into vertex form. Now, vertex form of the quadratic equation is very important. It directly tells you about the maximum or minimum value, right? So that is huge application for many examples. So if you have a parabola which is opening upwards, in that case we have at the vertex minimum value. Let us say the vertex is at hk, then at x equals to h, which is also called axis of symmetry, we have minimum value of k, right? So that is how these things are related. So axis is the line which goes through the vertex vertically. So as you can see here, we have axis of symmetry. This is the axis of symmetry, whose equation is x equals to h. The vertex, which we are mainly interested in, is the value, coordinate value h and k, where when the parabola opens upwards, we have minimum value of k. So that's the minimum value. Perfect. Now if you have something like this where the leading coefficient is negative, in that case the parabola may open downwards, correct? So in such a case, at hk we are going to have maximum value. Perfect. All other things remain the same. That is to say, in this case also we have axis at x equals to h, and maximum is at x equals to h. The value is k. So in the question, if you have to find the maximum value, you're trying to find k. If you're trying to find where will it occur, we are trying to find h. So that is how in real life situations we'll have many applications like throwing the ball, projectile motion, where the maximum reached and at what time it is reached could be found by the vertex. So that is the huge importance. Now let us see, given equations like this, how do we calculate the value for the coordinate h and k? We'll begin with the very standard form. The equation here, ax square plus bx plus c, is called the standard form, or sometimes we say standard form or general form. Of quadratic equation, right? So we'll begin with this. Once you understand the technique, you can do any equation. So we'll take up after this two examples. So these are our two examples, simple to begin with. Now let's try to understand the steps involved for completing squares method. The equation is y equals to ax square plus bx plus c. The very first step here is to factor a, the leading coefficient. So when you factor a, what do you get? You get x squared plus b divided by a, x plus c, right? So the first step involved here is to factor leading coefficient. Let me write down. So a is also called the leading coefficient. Factor leading coefficient a from first two terms. Now, first two terms, whenever we write standard form, we always start with the highest degree first and then arrange the terms. So you have to arrange the terms as written in this equation, right? That is important. Now, second step here is to add and subtract half of b by a. So we will add and subtract b by 2a whole square. So we are going to add and subtract. So when you add and subtract one term, it doesn't change the equation, correct? So half of coefficient of x, that is, so x square plus we have b by ax, we are going to add b by 2a whole square and also subtract b by 2a whole square from our equation. Now once you do that, in that case these three terms form a perfect square. So you'll notice that first three terms form a perfect square. So you could write it as a times x, the sign plus from here, b by 2a whole square, and we are left with minus b square by 2a. So let me rewrite this as b square. I am now opening this bracket, exponent. We got 4a square, clear? Plus c. So if you expand this binomial term, x plus b over 2a whole square, you get x square plus twice these two. That will give you the second term, and then the last term square. Got it? Now you can open this bracket applying distributive properties. So we get a times x plus b by 2a whole square minus a times b square by 4a square plus c. So you get the vertex form here almost. So b by 2a is axis of symmetry, right? So from here, let me go one more step combining these two terms, right? So we get a times x plus b by 2a whole square minus. Now you could cancel one of the a's, you get b square over 4a. So if I take common denominator of 4a, I get what? I get b squared. Now since I took minus outside, this becomes negative 4ac. Perfect. So you combine the constants, right? Distributive property. And simplify. So what you get here is the value of the vertex. Now in this case, you could see that the vertex is what? Minus b by 2a, which makes this 0. Correct? And that value here is b square minus 4ac over 2a with a negative sign. So these are your h and k values if we are writing this in the form y equals to a times x. Normally we write x minus h whole square plus k square, correct? So generally we write x minus h whole square. So the h value will be minus of this. Do you see that? And the k's value, k. The k value is minus b square minus 4ac over 4a by comparison. So that gives you the vertex of this particular equation. Now here, x equals to minus b by 2a is axis of symmetry. So I hope the steps are absolutely clear. We'll actually apply these steps and find the vertex for the next two equations. Now let us complete the square and find the vertex of this particular equation. So in this case, leading coefficient is negative. So we'll just factor out negative. We are left with x squared. Dividing by negative gives us minus 2x, and we'll keep this 3 outside. That's the first step. The second step is to add and subtract square of half of 2, right? Which is plus 1 square minus 1 square, right? So when you do that, in that case, first 3 terms will form a perfect square, which now can be written as x minus sign comes from there and 1 from there. Right? Do you see that? So we picked up the negative sign from here and the number 1 from there. So that takes care of the first 3 terms. Minus 1 square is minus 1. We get plus 3 here. Now we open the bracket. We get minus x minus 1 whole square, and minus becomes plus 1 plus 3. Combine the last 2 terms. We get minus x minus 1 whole square plus 4. You see that? Now the vertex here is 1, whatever makes this 0, and the number itself plus 4. Do you see that? Now if you want to sketch this parabola, it will open downwards, right? So we are not doing the exact sketch, but we are just showing you. It will open downwards since this sign is negative. So we have maximum value here. Since this is negative, it opens down. And the vertex is 1, 4. Axis is at x equals to 1. So we could actually write here that at x equals to 1, we will have maximum value of 4. So that is the importance of vertex form. You get the maximum or minimum depending on the leading coefficient. Leading coefficient here was negative, so we got the maximum value. Correct? Let's take the last example now. In this case, we have leading coefficient which is positive. So we expect a parabola which will be opening upwards. And in this case, we'll have minimum value. We have to find what, and at x equals to what. That is what we'll try to figure out. In general, we can write this as hk, correct? So let's apply our method. So we have y equals to 2x squared minus 16x plus 5. Factor out the leading coefficient 2 from the first 2 terms. You have to divide 16 by 2, you get 8x plus 5. Now, what should you do? Half of 8, which is 4. So you have to add and subtract 4 square. Do you see that part? Also see that I'm using square brackets. It is with a purpose, since later inside I'll use the other brackets. Now once you add and subtract 4 square, we have done completing the squares. And you'll notice that the first 3 terms inside the square brackets form a perfect square. X minus 4 whole square. Minus because it was x square minus 8x. Center term is negative. That is why. Minus 4 square is 16. You're only squaring 4, not negative. Now you open the bracket. So you get 2 times x minus 4 whole square minus 2 times 16, which is 32. Plus 5. Combine the last 2 terms, the constants, and what you get here is minus 32 plus 5 gives you 27. So we have a parabola whose vertex is at, what makes this 0? 4, and the number minus 27. So we have minimum value of minus 27 at x equals to 4. Do you see that? So h and k in this particular case is 4 minus 27. Perfect. So these are the steps which I hope are absolutely clear. Now it finds huge applications. Can you tell me where all we are going to apply it? As you can see, real life situation. We'll take up examples in the next video. So whenever you have something like this, that you have a projectile motion or you kick a ball or something like this, in that case, we can always find this maximum value using that concept. Perfect. Also, we have this in optimization. So when to use the minimum material and get maximum profit. So those are other very good examples where we are going to use the vertex form of quadratic equation and solve many situations. I hope you find this video interesting and useful. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'll be great. Thanks for watching and all the best.